Last month's launch of .NET 8 almost exactly coincided with the 60th anniversary of Doctor Who, and that's rather appropriate because in .NET 8 they've actually changed the way that time works, particularly so that we can do unit testing on applications that use time, and that's what we're going to be looking at in this video. So what I've got here is just a simple Blazor application where you can see we've got the clock at the top with hours, minutes and seconds, and it's ticking through every second, and then we've got this image of a bell, and the idea is when we hit exactly on the hour, then that bell is going to ring as many times as for the hour that we've got. It's not going to actually make a noise, it's just going to have an animation of a ring, but we'll see how that's working. And what we need to do is be able to apply testing to that, because it's quite difficult to test both for unit tests and actually for even end-to-end tests, because for an end-to-end test, for the bell for example, I can't test it now. I've got to wait till we hit the hour, and the next hour is only going to be 1 o'clock, so we'll check that it's rung once, but we won't have been able to check for all the other circumstances, like the fact at midnight it's got to ring 12 times, we'd have to wait until midnight. It's going to be quite fiddly to do. And also, even with just the basic clock itself, although we can look at it now and see that it's working, we can't check for all of those difficult circumstances. For example, this is supposed to be a 12-hour clock, but we can't see until we get to at least 1 o'clock in the afternoon whether it's correctly displaying the 12-hour clock. So all sorts of things that we've got to be testing. So let's see how it works and how we can add some testing. So if we just go into Visual Studio, we can take a quick look at how that works. So here we've got the Blazor page, and what we've done is we've injected this clock in here, which is a class we'll have a look at in a moment, and then we've used that. So in the setup timers that we call from onInitialized, we've got this time changed event, and that clock is going to fire that event every second. And all we're going to do is call state has changed, which is just the Blazor call to force a refresh of the page. And when the page is refreshed, we've also got on that clock object this displayed time, and so that's going to display the latest time, and so we tick over every second. But then we've also, as well as the time change that fires every second, we've got the ring changed, and that is going to fire when we've actually got the ringing happening on the hour. So for example, if it were 5 o'clock, then that ring changed would actually fire 10 times with this ring state, which can be either on or off, and so it would go through 5 cycles for the 5 o'clock ringing. And what it does, if the ring state is on, then it sets this image that we can see is bound on there. So we've got an image and also we've got a class on there. And so if the ring state's on, it sets the image to bell ringing and the class to shake, or if it's off, it sets it to bell still, and we don't have a class at all. And bell still is also that default image that we saw. And then that class that we have as shake, if we just take a look in the CSS, that's actually set up with an animation called shake, and so that's going to make the bell vibrate, and that's our visual view of it ringing. But we've got to wait until we're on the hour before we can do that. That's part of the problem. And if we go and have a look in the clock, then we can see here that there's our enum for the ring state being on or off. There's our displayed time that just takes the current local time and formats it in hours, minutes and seconds. We've got those 2 events that we're hooking up onto in the Blazor page, so the time changed and the ring changed. And then we set up a couple of timers, one for the main tick and one for the ringing. And then in there, we set the main timer to be every second and the ring timer to be every half second, every 500 milliseconds, even though we haven't started those up yet. Then when the main timer is elapsed, we simply invoke that time changed, as we saw over there. But then also we check to see whether it is exactly on the hour. So we look at the minute and the second, and if they're both 0, then into this fire ringing, we pass the current hour that we're going to use to count the number of chimes. And then we start off that timer, so that regular 1-second timer is just going to run all the time. Then in our fire ringing, we calculate the number of chimes. So got a bit of an issue. We've got to say if the hour is 12 or 0, so midday or midnight, then we're going to have 12 chimes. Otherwise, we have the hour modded with 12. That will mean that in the afternoon, when the hour is, say, 1500 hours, that will give us 3 o'clock, and so we get 3 chimes. And then when that timer is elapsed, we invoke the callback. So again, that's the ring changed we've got in there. And then if the state is off, we toggle it to on, and also we count down. If the state is on, we just turn it to off. We don't count down because if, for example, it were 5 o'clock, then we want to loop through this 10 times because we've got to have 5 ons and 5 offs. But finally, when the countdown reaches 0, then we stop the timer so it doesn't do any more. And then we can see we're just starting it when we come into that fire ringing. So that's how the code basically works. But as we've seen, it's very difficult to test because we've got to wait, certainly for the chimes, for us to be on the hour, which isn't easy at all. So we want to write some unit tests to help us with that. So let's do that. So let's go to our unit test file. And so this is XUnit, and at the moment, all I've got is a creation test, which is just going to give us that clock. So if we run those tests, we should see nothing particularly exciting. We've just got that one test obviously passed. What we need to do, though, is we need to introduce a way of mocking time. And so to do that, we're going to have to change our clock and inject into it one of these new classes, which is a thing called TimeProvider. So in the clocks constructor, I'm going to have this TimeProvider, and I'm simply going to call that TimeProvider, and then I'm going to set up a private read-only field of that type, and then just initialize that in here. So underscore TimeProvider equals TimeProvider. Notice I'm doing that in a full-blown constructor, not one of the primary constructors we looked at the other week, because I've got so much else to do in there. And then to start with, all I'm going to do with that TimeProvider, I'm not going to replace everything as yet, I'm just going to use it with this displayed time, because the problem with DateTime.now is that what we've got is a static property on a class. And that makes it very difficult to mock because you've not got an object that you can replace with another object, you've just got the class on which you're calling now. And so that's one of the big things that they're doing by putting in this idea of the TimeProvider. So we change that to underscore TimeProvider. And then on that, I can do a get UTC now. Now, a couple of things to notice here. One is, if we hover over that, we can see that this is not actually a date time. It's a data type called DateTimeOffset. And this was introduced a few versions back, actually. One of the problems with date time is, although it records a date and time, it doesn't record any sense of what time zone that is in. So if you created it from UTC now, that would be okay, but it wouldn't remember that it was UTC. It would just be a time, and you could get confused about it. What this DateTimeOffset does is not only has the date and time, but also an offset representing what time zone you're in, plus 5 hours, minus 3 hours, whatever that may be. So it always knows what time zone it's in, not just the time it is. And so that's a very useful thing. And so that's something I'd say happened a while ago. Another thing to notice is that previously we had now and UTC now as properties, but we've changed that to being a method. And it's a very subtle little issue here. But if you think of something like a property, when you call a getter on a property, that obviously should not modify the object itself. And that means if you call the getter repeatedly, you should always get the same result. But with something like now, or UTC now, if you call it repeatedly, even though you haven't actually modified it, it does change because time changes. And that's slightly at odds with how properties should behave. And so they've made it a method because it can give you different results each time. So that gives us the UTC now. And then also we want to turn that to local time. So that's easy enough. We can just say local date time on that. And that works really well because this thing knows its offset from the local time, and so it can work that out very easily. And so that's injected the TimeProvider and made use of it. We've got to configure that injection, so let's go to the program, and in here you can see that's where we configured the clock for injection. So now I'm going to say builder.services.add singleton, and it's going to be of type TimeProvider. And then the actual object we're going to give it, we can simply say TimeProvider.system. So the TimeProvider class has a property of type TimeProvider, the system TimeProvider, which is the normal one you'd use. So when we're not trying to replace this for testing, that's what we'd have. Notice actually we don't need the generic because it can infer the type there. So we'll just get rid of that. But that should mean that now when the clock's created, it will get the standard TimeProvider. And if we run up the application, we should see that nothing's changed. It's still going to be displaying the correct time, but it's getting it from the TimeProvider now. As we can see there, that's all working perfectly well. Now though, we can start writing some tests for it. So if we go back to our test code, well actually, we already can see that it's got a problem now because we've got to provide something to that constructor. So we need to provide a mock time provider, and we'll do that with a mocking framework. Until recently I might have done that with mockq, but because of the security issues that have arisen over the past few months with mockq, I've switched generally to using NSubstitute. So that's what we use here. So what I'm going to do here is just type in substitute, and let's install NSubstitute for that to get it all working. Shouldn't take too long. And then we can say .for, and then what we want to do it for is this time provider. So not an interface, but TimeProvider has lots of virtual methods that we can override, so that's going to work fine for having a substitute there. And just for the creation, we don't need it to do anything. We can just run that and we'll see that it all works fine. But now we can actually start testing, at the very least, that property displayed time, which is using the time provider. So if we go in here, what I'm going to do for this is this one I'm actually not going to have as a fact, I'm going to have as a theory, because I want to test it for various different times. And so we'll pop in an inline data, and for the first one I'm just going to just have one of these. We'll build up the other ones later on. So I'm just going to pass in 1, 2, 3, and then I'm going to have 0, 1, 0, 2, 0, 3. So what we're saying, if the hour is 1, the minute is 2, the seconds is 3, then that's the way that it should be displayed. And so we'll have our public void. We'll just call this displays correct time. And that's going to take in int h, int m, int s, and then string expected as those 4 parameters. And then we need to start testing for that. So what we're going to do is we are going to create our mock provider. So provider equals, and then exactly the same code we had there. And then we're going to tell it how to behave when that method getUtcNow is called. And so what we're going to do is say provider dot getUtcNow. Doesn't have any parameters, but then we can say dot returns, and then we can pass in our new DateTimeOffset, and we can set that up. We just hard code the year and the month and the day, and then we pass in our H, M, and S that we've got for the tests. And then remember, this is a DateTimeOffset, so you don't just give it a date and time, you also give it the offset for your time zone. But we're not worried about that, so we can just use default. So that'll be the default for time span, which is just a time span of 0. So that's basically setting it to local UK time. So that means that whenever somebody tries to call getUtcNow, they'll get back the time that's under our control. And then, simply enough, we create our clock. So var clock equals new clock, passing in the provider. Easy enough. And then, straightforward, we just say assert.equal, and then expected, but not clock.toString. Remember, it's clock.displayedTime. So that should be working okay. Let's run the test, and we can see that passed perfectly well, and it displayed the correct time for 2 minutes and 3 seconds past 1 in the morning. But now all we need to do is add a few more examples of those, particularly to deal with corner cases where the rules may change slightly. So one of the ones to watch out for is at 12:59:59. So just before we have any issues to do with the 24-hour clock, that's going to be 12:59:59. And then just after that, so at 13:00, that wants to be displaying 1:00. Okay, because it's displaying 12-hour clock. And then also, let's just check for midnight, should again display 12, because that's the way that the 12-hour clock works. And so if we run those tests, then they're all passing. We've got rather more of them. But you can see, you might find some other ones you want to add, but that, I think, covers the basis pretty well. So we've got the first test working, that it actually displays the correct time. But if we look back at our clock, we can still see that it's using the old-fashioned ways of doing things, particularly for kicking off these timers, and that's going to be a big problem for us to start mocking. So we're going to need to make some changes there as well. So I'll start just by doing that for the main timer that ticks every second. And so what we do for that is we don't actually need this timer anymore. So I'm going to get rid of that. And I'm going to get rid of that. And that. And then this timer elapsed, I'm actually going to change that to be a local function. We could do it with a lambda, but it's easier with a local function. So I'm going to have a local function that I'm going to have void, and I'm going to call it tick callback. And that's going to take as a parameter a nullable object. So basically, it can take any data you like, though in fact we're not interested in it. So we're just going to have that set like that. And then that's going to do the same thing on the tick. It's going to invoke the time changed, so the clock on the screen should update. But then what we're going to do is to create that, we're going to say underscore TimeProvider dot, and then we've got a method on here called create timer. So that's how we set them up now. And again, because it's coming from this TimeProvider, we'll be able to mock that create timer and do things in our own way. And so the first parameter in there is this callback, so tick callback. So that's what we pass in there. It's actually of a type called timer callback, but that just matches the signature that we've got there. Then the next thing we pass in is this thing called state, and that's basically that same nullable object that gets passed into our tick callback, so we're not interested in it there. But then we have the due time. So you don't have to start your timer immediately. You can have an initial offset, but we don't want an initial offset. We want it to start immediately. So again, default time span is 0. But then we've got the period, and that's when we can actually put what's happening here. We want this to go every second. So we're going to say new, then time span, and then 0, 0, and 1. So that will kick off every second. So what we've done there, we've created the timer. It starts immediately, and we never need to stop this one, so we don't need to worry about that. And so this tick callback will get called every second. And so having done that, that should now be working. And before I actually write the test to use that, let's just run up the application and check that that part of it still works. And so there we can see that the clock's still ticking, so that's okay. Let's now write some tests to actually verify that. So we'll go back in here. This one, we only need one test just to test that it works. So we'll have that as a fact, and it's going to be public void. And then I'm going to call this tick fires event. And what we'll do in here is the same sort of setup. So we'll start out with our provider as a mock. Then what we're going to have to do is capture the callback that was passed in. So here, this tick callback, because we're mocking the timer, are now going to have to call this one. So what we're verifying is that when we call it, that invoke gets called and the other bits and pieces, basically. So that's what we're trying to do. So what I'm going to do is actually use that type I mentioned, timer callback. So that's the type of that callback. And I'm going to call this tick callback, so the same name as we used in the clock class. And then this has got to have an initial value. So we'll just set it up like that. And that O is rather nicely being inferred as being of type nullable object because we've got that in there. Now we still need to mock the get UTC now, so we'll put that in there. Now, of course, we don't have the hours, minutes, and seconds now, so we're just going to change that to be just some random time, 12, 15, 30. That should do the trick. But then we're also going to mock the create timer. That's the key thing we're trying to work on here. So we're going to do provider.create timer, and then the first parameter to that is where we need to capture this tick callback, because the first parameter is where that's being passed in. And the way we can do that in NSubstitute is like this. What we say is arg.do, then we have the parameter type, which remember is timer callback, and then we can pass in a lambda that will be called when this parameter comes in. So I'm going to call that C gives, and then tick callback equals C. So that C is of type timer callback. That's basically the parameter that's passed in, which will be this thing here, the tick callback. And so we're going to assign it into our local variable. Then we just need to deal with the other arguments. So the next one, arg.any of type object. So we don't care about that one. Next one is going to be arg of type any for a time span. And then the last one we're going to be a bit more specific about. So that one is going to be arg.is. So it wants to give us an exact match. And what it's going to be is the time span that we passed in here. So if we take that, and then just pass that in there. That means that's the one that we're going to match there. And then that's got our create timer. So that's going to basically pick up the callback because we have to invoke the callback because we are replacing the actual timer. We don't want to wait, we want to do it straight away. Then we can create our clock, passing in the provider. And then remember what we're trying to make sure is happening is that this event is fired. So the way we're going to do that, I'm going to just say int fire count equals 0. Then I'm going to subscribe to the event. So clock dot time changed plus equals, not that. It's going to be a lambda, taking the sender and the events, and then that's going to give fire count plus plus. So every time it's called, that's going to happen. What we then have to do is actually make time happen for ourselves. So we're going to have to take that tick callback and invoke it, passing in null because we don't care about that parameter. And then finally, once that's happened, that should have fired time change. So fire count should be 1. So we'll do there our assert dot equal and then 1 and fire count. Okay, so that should verify that that's happening correctly. Let's run that. And that's working fine. So that's working okay. And we saw it was working on the screen as well. Next, things are going to get a bit complicated because now we've got to do the testing for the chiming. And I'm going to actually write the chiming code first. You might want to go for a test-driven development approach in real life, but certainly in this case, I think it's easy to understand if we see the implementation before we see the test. So let's go back to our clock and start sorting out that issue. So at the moment, we're still using the traditional timer that we can't mock. So we've got to make some changes there. First thing we've got to do, we don't want to be using datetime.now here anymore because that would give us the actual time, not the mocked time. So what we want to do here is say var now equals, and then we're going to use the timer provider, get UTC now, convert it to local because we want the local time. So that's really exactly the same we're doing there, apart from not turning it into a string. And then we can simply replace each of those with now. So we're going to check for the minute and second on the mocked time, and we're also going to fire off the ringing for the mocked hour. So that's what we've done there. We're also going to get rid of this ring timer at that point, and I'm actually going to change the definition up here to be not a timer, but an ITimer, which is a new interface that came in along with TimeProvider, as we'll see in a moment. So we'll just put a using in there for that. And also, I'm going to make that nullable because I'm not going to be initializing it in the constructor. I'm going to initialize it only when we get into fire ringing for the first time. So that's what we've got in here. Then in here, we can leave those first two lines the same, just setting up the countdown and initializing the state. Once again, we're going to replace this elapsed with a local function, and this one we're going to call ring callback. And again, it's going to take a nullable object that we're going to ignore. And most of that code is going to be the same, but we'll see some slight changes. What we're then going to do is we're going to say underscore ring timer. And then we're going to use a really handy thing, the null coalescing assignment operator, which I'll come back to in a second. Double question mark equals. And what I'm going to do here is say underscore timer provider dot create timer. So we're going to do the create timer once again, but this time it's going to be for the ring callback that we've just set up down there. We can still pass in, just go up to compare what we're doing there. We can still pass in null for the parameter, default for the due time, and then for the period, we're going to have this one slightly different because remember, we didn't want it to be every second because we want it to toggle on and off. So I'm going to change that to 0 seconds, 500 milliseconds. So that creates our timer, and you can see create timer returns one of these ITimers that we're going to make use of. The null coalescing operator, been around for a little while in C#, really nice thing. What it does is it looks at ring timer, the thing you're assigning into, and if ring timer is not null, then it just leaves things as they are. But if ring timer is null, then it assigns into it whatever you've got on the right-hand side. So that's really nice for a delayed initialization that we can just put something in there, but the second time we come in here, it'll already have that, so we don't have to worry. Then in our ring callback, as I say, we don't have to do very much. We still invoke the event, we still toggle the state and do the countdown once every other time this is called, but the only thing we've got to change is how we stop it, because we don't have a stop Instead, on this ITimer interface, we've just got one useful method called change. And what that allows us to do is change the due time and or the period to be something different. And so for the due time, we want that to be default again. But then the way you stop one of these timers is you give it a time span of a thing called timeout.infinite time span. And that's the deliberate way that you turn it off by giving it an infinite time span. Got to put a question mark in there because it's a nullable reference. Get rid of the start, because remember we said these things start off automatically. One other thing we've got to do though, because that ring callback has set the time span to infinite, before we start, so when we come in here, we've got to reset it to 500. So here I'm going to say underscore ring timer dot change, and then I'm going to put in these last two parameters here again. It looks a bit repetitive, but remember that code that I've got highlighted is only going to get called the first time, not subsequent times we come in here because of the null coalescing operator. So that will set it back to 500. So it will be start off at 500 and then stop when we run out. So that's the new code that uses the TimeProvider and the ITimer interface. And as we can see, that's removed all references to the date time and datetime.now and that sort of thing. We're using everything off the provider. Now, we're not going to be able to actually run that and see it working because, again, we've got to wait till we're on the hour to see that. So the best I can do is just build that, check we get a clean build, which is working okay. And so now let's go in and write a test that verifies that that code works correctly. So back in the clock tests, I'm going to do another theory. And again, I'll just give it an initial line of data. So what I'm going to do here is basically say, if it's 5 o'clock, then it should chime 5 times. Okay, so that's what we're testing for. Obviously, it won't always be that because we know things like at 1500 hours, it's going to chime 3 times. So that's why I've put the 2 parameters in there. They won't always be the same. So we've got our public void, and I'm going to call this ring count correct. And then that's going to take the int, which is going to be the hour, and then the int, which is going to be the count. Now, before I get into the detail of this, I should point out that this sort of testing really is quite tricky to work out how to do. And although I'm going to show you what works, I spent a long time trying to get my head around exactly how to do this sort of testing, because when you've got these callbacks and things like that, you've got to be quite subtle about how you put it together. So although it's going to seem like I'm just showing you this is how you do it, it's obvious. It's by no means obvious, and if you come to a similar problem and start thinking about it and scratching your head, that's perfectly normal. You're not ever going to be expected to be able to kind of write this sort of thing out straight away. So just to warn you that I've thought about this before, I'm not just making it up as I go along. So what we're going to do here is we're going to, once again, start by getting hold of the provider, and then also we're going to be mocking the timer. So we're going to do var timer equals substitute.for, and then it says timer, but this is actually going to be for our ITimer. So that's the class, remember that in clock, is what we're getting back with this ring timer. What I'm also going to do is I'm going to have a nullable time span, which I'm going to call period, and I'm going to initialize that to null. And what this is going to be is I want to pick up on the period that's being passed in. So either the time span of 500 milliseconds or the infinite time span when it's terminates, because I need to know that so I can check that it's terminated after the right number of iterations. So that's what we've got in there. And then on that mock timer, I'm going to do similar sort of thing to what we saw on the mock provider. I'm going to say that when we do the change, I don't care about the first parameter, so that's going to be arg.any for time span. But on the second parameter, that's the one that I want to pick up and put into period. So on there, I'm going to have the arg.do for time span. And then you can see it's worked out what I want. So I want to take C, which is going to be the time span. I won't call it C, I'll call it TS, a bit clearer. And then when that change is called, it's going to put that in there. So that's going to be called both on the reset to 500 and also on the set to infinite. Then I'm going to need to have the setup that we've got here where we have these various things. So I'm going to need my tick callback. I'm going to need my mocking of the get UTC now, and I'm going to have my mocking of the create timer for the tick timer. So let's copy that and put that in here. But then the slight change I'm going to make is the actual date and time it returns is going to be the hour that we've passed in, and then because we're trying to get it to chime, we're going to have the 0 and 0 in there. So that's what it's going to return, and that'll pick up our tick callback. But we're also going to have the other one as well, so I'm going to duplicate that and do another one for our ring callback. So our ring callback is the one that's being passed in there. And in the tests, I'm going to do another mocking of create timer, and this one is going to be for the ring callback. So I'm going to pass my ring callback in there, and then at the moment they're exactly the same. What I want to do is change this one so it matches the appropriate setup. So because that one's 1 second, that one's 500 milliseconds, it's going to count those as different mocks. There's other ways I could do that, but because on different times, that's the easiest way that we've got to do that. And then the last thing I've got to do is on this second create timer, remember this one is actually getting back this ring timer. So the main one that we had here, we didn't bother with the ITimer because we never wanted to stop it or change it, but this one we do. And so I'm going to say dot returns, and then we can pass in the timer, the mock timer that I created earlier. So that's what will get handed back. So that's what it will call, and therefore we can see when it's changed. Having done all that, I can now create my clock. So var clock equals new clock, passing in the provider, just as we've done before. And then, rather similar to what we did with this fire count, I want to count the number of times that the ring changed event on the clock has been called. But we want to check it for both sending back the on state and the off state. So I'm going to have two counts. I'm going to say int ring on count equals 0, and we'll duplicate that for the ring off count. Okay, and then we're going to, on the clock, get hold of that ring changed event, and sender and args, and in this case we're going to say if e double equals and then ring state on, then as it's done there, it's going to increment the ring on count, else it's going to increment the ring off count. So simple enough, that's going to make sure it's counted the right number of times. Then we're going to have to keep the whole thing off, so that's done with the tick callback, passing in null again. So remember, the tick callback is going to be invoked up here. That's where it's going to check to see whether we're bang on the hour using the mocked time we gave it, and so that's when it's going to fire the ringing. So we've got to call that one once, and then comes the bit that's probably most tricky, because we've got to actually do the firing of the timer to get the ring callback to go, and we've got to get that the right number of times. And so this is what the hardest thing to think about was. What I ended up with was this. I'd say while, and then that period that we'd set up here that is going to get changed when we do a timer.change, I'm going to say while that period is null, which it will be to start with because we set it to null, or period.value, because it's a nullable value type, doesn't equal, and then that timeout.infinite time span, because that was the thing that we set it to do down here. So basically we'll keep going until that line of code gets called. And then all we have to do in that loop is keep invoking the ring callback, passing in null. And so that will just go round and round and round until eventually we've rung the appropriate number of times. Then we'll hit the infinite time span. That will pick it up. It'll stop doing the ring callback. But we should have picked up the count in there. So finally, all we need to do is assert.equal, and then the count that we passed in right back at the beginning up here, and also exactly the same for the ring off count. Okay, so quite complicated what's going on there. Let's just talk through it again. So we create the mock provider, the mock timer. We configure the timer so that whenever change is called, we're going to put that period into period. So that's how we check for the infinite period that it's ended. We then create callbacks for both the tick and the ring. We also mock the current time to be on the hour for whichever hour we said. There we get back the tick callback. There we get back the ring callback. And also on that, remember to return the timer. Set up the provider. and then we subscribe to the ring changed on the clock so that we'll count both the on state and the off state. We kick the whole thing off by calling the tick callback, and then we loop through, repeatedly calling the ring callback until effectively we're told to stop, and we're told to stop by the fact the period will have been set to infinite, and then we check the counts. And with a little bit of luck, we can see that that's working okay. Let's actually go through that again, and I'm going to go through it in the debugger just so we can really see what's happening. So what I'm going to do is let's put a break here and run that one in debug. So there, we're invoking the tick callback. If I F11 into that, we can see that it obviously invokes that one. We're not really interested in that. It will get hold of the fake time, so that is going to be 5 o'clock exactly, and that means obviously that we'll come into fire ringing. If we go in there, and then now we just set those things up. Now is when this time we're going to find the ring time as null, so it will create it for the first time, but we also change it back to 500 in case it was the second time, and basically we leave that. But now when we come into here, if I step into the ring callback, now we're coming in there, we invoke it. So if we step in there, we can see that's incrementing the on count, and then we go through, we toggle it. We're not at 0 yet, so back in here we go around again, come in again. This time we're in the off state, so we decrement the countdown, and so on and so forth until that all works. So we can see, quite complicated, but that is all working. Let's now put on those extra rows of data, and so in here, remember what we want to check for particularly is those corner cases. So 5, 5 is an easy one, but one of the corner cases is going to be 0 and 12. So 0 is midnight, but you want 12 chimes at midnight. Another one we'll check for is noon. Should be fairly obvious, but I'd count it as a corner case, because the other one we're going to look at, say, is, let's say, 1500 hours, which is 3 o'clock, and therefore that should be only 3 chimes. So if we run all of that, then again, we're getting all of those passing, and so we can see each one of those has worked. So that's all working, but of course we don't feel confident because we'd like to see this thing actually up and running and see the chimes on the screen, but we can't do that because at the moment it's only 26 minutes past 1, and we'd have to wait until the hour before that would work. So the next thing we're going to do is actually put something into the Blazor component itself which will let us really test it. Now this is a bit of an odd thing to do because you don't normally want test code in your application code, but I think it's necessary here to make that work. So what we're going to do is this. We'll go to our Blazor page, and then up at the beginning of this, I'm going to put in another section. And in this section, I'm going to put a label. I'm going to make it a label for a thing that I'm going to call cheat check. And then that label is going to be force chime, and then after that I'm going to have an input checkbox. I'm going to give that the ID of cheat check, so that means the label will apply to it, and then I'm going to do an @bind value onto a thing I haven't created yet, which is just going to be a flag called use cheat, and then I'm going to do an @bind value :after, and that's going to bind onto a method that's going to be called after the value has changed. So that's why the after's in there, and again I haven't written that yet, but that's going to be called cheat change. And so what I'll then do is on here I'll just put in this private bool, which I'm going to call _use cheat, and that should keep that happy. And then I'm going to put in, just for now, an empty method, so I'll just have a private void cheat changed, and then put nothing in that for now. And as I say, this code, particularly this bit, you could make it so that that will only get displayed if you've done a development build rather than a release build or something like that. Some way to remove it when you don't want it, but be able to easily add it when you want to do some actual end-to-end testing. Now let's do a bit more work here, because what we're going to need to do is we're going to need to mock our TimeProvider. But we don't want to use NSubstitute because this isn't really unit testing code, it's not in the test project, so I'm going to mock it directly. So what I'll do is, if we go into the logic application, and then I will add a new class, and I'm going to call this class offset TimeProvider. Make it public because it's going to be needed in a separate DLL, And then I'm going to derive this from the time provider that we've been looking at all the way. And remember, that's got virtual methods, so I can just override the ones I want, ignore the ones that I don't. What I'm then going to do is in here, I'm going to have a private read-only time span, which I'm going to call offset time. And then I'm going to have a constructor. And in this constructor, I'm going to get hold of the actual time. So I'm going to say var now equals base.get UTC now. So that's definitely going to be the real time. But then I'm going to say that this offset time equals now minus, and then a date time offset, which is going to be the same year, the same month, the same day, the same hour, but then it's going to be at 59 minutes and 55 seconds. So when we kick this thing off, it's going to basically be setting the time to 5 seconds before the next hour. So then we should see a nice 5-second countdown, and then we can see the chimes working, and that'll be great. Remember, we've also got to put the default offset for a time zone. So that's what we've got there, and I've missed off new on there, so that'll sort that out. And so having done that, I'm now going to override the get UTC now, and what I'm going to return is the actual time, but then I'm going to subtract the offset that we just created. And so that's what means whenever we ask for the time, it'll be offset by that amount, and so that forces it to 5 seconds before the next hour. So that's what's going to do our cheating for us. Now we've got to get that injected into the system. So what we now have to do is go to our program, and there we've got our main injection of the clock. But what I'm going to do is I'm going to say builder.services dot, and then I'm going to add keyed. So this was the key dependency injection we looked at in the last video, and I'm going to do this as a transient. So the singleton's fine for an actual clock, but we want this to be transient because we want the constructor to be called every time we kick one of these off, so that we get a different offset time. So that's why I've gone for transient. It's going to be keyed on something like, let's say, with offset, and then I'm going to return a specific clock. So I'm going to use a lambda. That's going to take two parameters, P and K. And what those are, P is, if we hover over it, actually just the service provider. So if we needed to get hold of any other services, we'd use that, but we don't. K is actually the key. So whatever we had here, with offset in this case, would get passed in, but I'm not interested in that either. All I want to do here is return a brand new clock, and I want to pass into that, not the system time provider, the normal one. I want to pass in an instance of this offset time provider that we just created, and so that means that we'll be using the fake one, which will make that countdown work. So there we've set that up. And notice we can have both the regular service and the keyed service at the same time. And if we don't provide a key, it'll just give us a clock. If we do provide the right key, it will give us this clock with the fake one in there. Back then to the Razor application. And what we're going to do is, as well as injecting the clock, I'm going to do an @inject of the iService provider. Because remember from the last video, I need that in order to get hold of any keyed services. So we've got that there, and then back into our cheat changed, I'm going to say _clock equals, interesting to note, when it injects into a Blazor page, that is not made read-only, which is quite handy here because I want to change it. So I say that equals, and then if that use cheat flag is true, then I'm going to get hold of this clock using the offset time provider. So I'm going to say provider, that's my service provider, dot get required keyed service, and then that's going to be of type clock, and it's going to use the key that we just put in there of with offset. Otherwise, we're just going to use the regular clock. So again, we can say provider, and this time it's just get required service without the key, and so that's going to get the regular clock. So we can see that we had the two different ones we set up there. We can get either of them in those slightly different ways. And then finally, we're just going to call this setup timers again that was called in the initialization, but because we've changed the clock, we need to set them up again. And so we can do that easy enough. And so that means with the checkbox, when we check it, we'll create a new one of these offset timers. We'll do the countdown, we'll see if the chiming works, and then when we turn it off, we'll go back to regular behavior. And so that should all be working. So now if we run that up, and we click the checkbox, so now we can see it's gone to 5 seconds to 2, it's counting down, and then we hit 2 o'clock, rings once, rings twice, and then it stops. If we uncheck it, we go back to the regular time, and if we check it again, because it was transient, creates a brand new one, so we're back in there, and once again, when we get to the end, rings once, rings twice, so that's working okay. Again, the determination that it gets it right in multiple circumstances has been done by the unit tests, but in terms of just a visual check, we can see it's all working, and we get that nice animation going. So, that was really quite a lot of work you had to do, even though we've added these two things to .NET. We've got the TimeProvider and we've got the ITimer interface that you get back from a Create Timer. But as with anything to do with time, it really is quite tricky to test it because in the normal flow of things, it's completely out of your control and you've got to take control of it using the techniques we've seen here. Still playing more of the .NET 8 new features that we've got to look at. So if you enjoyed that one, do click like, do subscribe, and I'll see you next time.